Good morning, good afternoon, good evening, and welcome to Texas Cyber Summit. My name is Bango. I'll be your speaker for this presentation, and we'll be talking about building the next generation of secure developers. And this is something that's near and dear to my heart. I've been a developer for quite some time. Actually started programming in 1989, and I've seen a lot of things over the course of my career. And more recently, I shifted over into security because it piqued my interest, and I really wanted to help people just build more secure systems. And I felt it was a natural fit for me to shift into application security and start learning about some of the dynamics that go into that. So as we go along, I'll talk a little bit about some of the things that I've learned, hopefully share some of the experiences, but also try to share ways that we can help new developers coming into the environments, into the corporate environments, learn how to build more secure systems and also help the existing developers think about the way that their apps are being built and think about security as a priority when they're building those things out. So, when I think about developers, I think about them in three main buckets. Now, mind you, this doesn't encompass every single type of developer. I know that, I understand that, but it's just the way I conceptualize it. I like to conceptualize it in terms of enterprise developers, the breadth developers, and the open source developers. And let me touch on each one of them. So you have the enterprise developers, and they're building systems for corporate environments. A lot of the systems that maybe many of you use day in and day out. They're a little bit more conservative in their stack because there's business continuity concerns, and they have to be very considerate of their users. It can affect everything from your ability to withdraw money from a bank to actually buying your groceries. And so there's that sense of let's be careful, let's do things calmly. Their adoption cycle is a little bit slower because they want to be more methodical and they also have to make an investment in the technology stack. So they're trying to be very cautious. Then you have the breadth developer. And the breadth developer, if you've ever worked at a startup, that's kind of the breadth developer mentality I think about. These are folks who are what is it? What's that saying that goes, move fast and break things? They're a little bit more open to embracing more nascent technologies, newer technologies that are coming in. They are definitely open source fans, and they're willing to take those risks in order to have an advantage in their marketplace. And so both are actually very equally important, but just different mindsets in the way that they approach technology and the way they approach technology adoption. And then you have the open source developers, which I'm a big fan of because these folks are doing things for a labor of love. Sometimes they've built a project that they find very cool and they just want to get it out and they want to share it with the world. And sometimes these projects turn into major supported efforts. So I think of like the jQuery project, which I was a member of. And so that became a very important library in the course of web development. And there's so many other examples of that, everything from Linux, the Linux operating system, to uh, Kubernetes, to all these other tools like Python and Golang and things like that. These are all open source efforts now that are really important to the overall development ecosystem and the overall information technology ecosystem. And so, uh, near and dear to my heart. But these are the way I kind of think about developers. Again, each one of them could have their own little subtrees below it, which describes them independently. But I just like to think of them in these buckets, and the reason is because there's that way I can kind of conceptualize what are their needs. And this is something that's really, I think it's something really important for you as security practitioners to think about. What are the needs of these individual buckets of developers, and how can we get them to think about security within the context of those needs? So part of the problem is that what do security folks think of that developers do? Well, and this is from experience. I know I'm generalizing, but this is the general feeling I get sometimes when I speak to security folks. Security folks think that developers are rock stars. They're kind of like Jonas, the Jonas Brothers. I think this is Nick Jonas here. My daughters, of course, would know this for sure because they're all Jonas Brothers fans. But they're rock stars. They're hanging by the beach. Oh, we're coders and stuff like that. And it's being a developer. I can tell you, it's far from the truth. There's a lot of pressure and demands on them. They're not soaking in the tub, being served drinks. But I know there's that misconception. But then there's also a misconception by the developers saying, they have their own perceptions about what security folks do. And they think security folks are like Voldemort coming down and striking fear into everybody saying, you cannot do this. You have to follow the security protocol. You cannot touch this. And so there's always these challenges in between the two groups. And you want to try to balance out the need for the developers to be able to have the capabilities they need to build the stuff that they want, while also doing it in a secure fashion. And so two very different groups that are there to complement each other, but ultimately to to stay safe. I guess that's the best way to describe it. So I see security practitioners as protectors. I mean, that's what they are. Now that I've been in the security industry for about 4 years, I truly believe that there's this just genuine interest of security professionals to protect the systems. That's what they've been empowered to do. That's their job. And so they want that. They want to make sure that all these security protocols that they're putting into place are respected and adhered to, and they're doing it for a reason. But there has to be some flexibility. There has to be a little bit of a give and take, and that's where it's a dual responsibility. And I see developers as builders. They're trying to build the next great experience. And as security practitioners, we have to enable that. We have to figure out how do we give them the tools and the capabilities to be successful when they're trying to build things that will allow the business itself to be successful. And let you in on a little secret, since there's so many security practitioners probably listening on this talk. Uh, Software development is really hard. And just like security is hard, software development is so hard. If you look at the landscape, and I'm not touching on everything for sure, there's everything from 25 different types of programming languages at least to different platforms like mobile, and you have infrastructure as code. You have all these frameworks that go out there. Not to mention now that the complexity of DevOps and how developers are now they're taking on this responsibility of building the infrastructure and managing it. And so there's a whole level of complexity across so many different types of platform plays, integration. You have WAFs, of course. You have bug tracking. All these things, they just add a tremendous layer of complexity to the development lifecycle. And developers, I have to say, I'm sure they're feeling a little overwhelmed by all the things that are coming down the pike and all the things that they do. In fact, I'm pretty sure this was a developer who was feeling that at one point. And it's interesting. You look at the stickers, and I'm actually like, wow, I'd like to go back to those times when it was only HTML5, CSS3, PHP, maybe Node. Those are the simple times. But you can see this poor developer putting his hand on his head, thinking, "Oh God, how do I deploy this in a safe way?" Or maybe they're just thinking, "How do I deploy this in general?" It's an interesting challenge for these developers to think about, and it's not an easy task by any means to be a developer now in modern times. And most developers think of security as it's an IT problem. It's not. If you think about it, it's like, oh well, this that they have to write. They have to put in security controls like access to systems and things like that. They have to, I don't know. They have to load a WAF. They have to have an EDR system. Those are the ways that developers, I think about security from an IT perspective. And it's not so much the code perspective, but from the IT perspective. So when they have somebody from IT coming in and saying, you need to think about security and you can't have accesses, it's almost like if security adds more work. It's like it's killing their workflow. And developers work in a flow. They're trying to get things from the development cycle to staging to production, and in between, there's a whole lot of other things that go into it. And so security to them adds friction to the way that their workflow happens, and it's hard. It's hard. And if you think about this, these are some scary numbers. In a recent ESG survey of cybersecurity professionals, 35% of respondents reported that less than half of the development teams are participating in formal security training. So that means that there's a boatload of development teams that just really have no concept of what modern security practices are. And it's not to say that may not be writing secure code. Thankfully, a lot of the managed codes, managed runtimes nowadays help with certain things in terms of security, but it doesn't cover everything. And then also, you think about this, only 3% of US bachelor's degree graduates have cybersecurity related skills. So not only are the folks in corporate America not getting the training that they need to actually learn security, but they're not being taught in the schools, and that's a scary proposition. And this last one is really scary as well. 76% of apps have at least one security flaw, and uh, and that half of security findings are still open 6 months after discovery. And so what that tells me is that not only do we not have security skills being taught at schools, and we don't have security skills being taught at in corporations, we're also having to prioritize what those security issues are when it comes to pushing code into production. And so, if the developers don't have an understanding of what the prioritization of a security issue is, it makes it hard for them to figure out when should I tackle it. Is it just a bug, or is it a legitimate critical security issue? And as we look at some of the things that have happened in our industry, like the dependency confusion issue that affected things like NuGet and other package managers, or package manager supply chain attacks, like what happened in PyPy and npm, where malicious packages were inserted into these repositories. This kind of really shines a light on the fact that we need to get better at exploring what security issues actually look like, and especially modern development stacks like Node or Python or other languages like that do allow developers to ingest third-party packages. There has to be a way of doing that in a secure fashion, whether it's through software composition analysis, which also ensures license compliance, and license compliance is a big deal, separate from this talk, but that is something that's really critical to business continuity. I think we need to really talk with developers a little bit more about license compliance and where that fits into the conversations. But then we look at the OWASP top 10, and the OWASP top 10 continues to be the bane of existence for security practitioners. Why? Because some of the things that we would have expected to have been resolved by now through the best practices of groups like the OWASP, I'm tongue tied, the OWASP organization, they continue to show up. And so things like cross-site scripting and SQL injection attacks and XML external entity attacks, these things continue to be pervasive in the industry. And it shows, again, this lack of understanding of where these things sit in the development lifecycle. We need to get better at that. We need to show developers how these things can affect them, and we need to enable them and give them the tools to better learn how to solve those challenges. And so, why is this happening? Well, in many cases, again, graduates are coming out of computer science courses, engineering courses, and they really don't have an understanding of what the threat landscape is. And, it's not their priority. They're being taught computer science. They're being taught whether it's C++ or Java or algorithms or conceptual, topics. That's just the way that universities teach now, and it's not a failing of the student themselves. I personally believe that universities need to do a better job of teaching students secure coding principles. I think that's critical. We need to get these universities to consider security a top priority. And when you take into consideration things like the new executive order, the cybersecurity executive order by the White House, where things like static analysis and fuzzing and software composition analysis, and having a software bill of materials are now requirements in order to work with the federal government. I think it's important that universities start considering this as part of their curriculum to help these graduates coming out be successful in the workplace. But it's also a lack of employer investment. So many times these students come in and they take a job and there's no formal training, there's no onboarding. Nobody's saying these are the patterns and practices you need to understand about in order to make sure that the code you're producing is secure. And here's training that's going to help you do that in a better fashion. There's Unfortunately, I almost feel like there's a lack of incentive to make security a priority versus the business value of what they're building. And that's a hard one to solve. That's more of a C-level conversation. Executive management needs to really think about that. And with the number of breaches that have been happening and the effects that those breaches have to brand recognition, customer satisfaction, customer loyalty, and customer trust, I think it's important to start thinking about where security sits within the life cycle of development. And A lot of people think that the cloud is, the end all be all. It's going to solve everything, and I think the cloud is solving a lot of things, especially when it comes to scalability and ease of deployment. It's making things substantially easier than having, I don't know, 1,000 physical servers sitting in a data center. So that's great. The cloud is awesome. I support the cloud wholeheartedly. But the thing is that we can't conflate the cloud security mechanisms with application security. I think the cloud is making infrastructure more resilient if you deploy it the right way. If you have somebody who's really knowledgeable in cloud deployment and they put it out there, whether you're using Azure or AWS or GCP or whatever, if you do it the right way, you're going to have a fairly resilient infrastructure implementation. I've talked to enough people that I feel really strongly about that, but this doesn't solve the application side. And in fact, what's happening is because these cloud infrastructures are much more resilient, these threat actors are now shifting to the application side and trying to find ingress via vulnerabilities in the application that developers are building. And they're being successful. And they're being successful through supply chain attacks or things like SQL injection, where they can get a web shell and drop it on there. Web shells are pervasive. Microsoft did a really good blog post. I'm going to say it was last year. Was it last year? Anyways, they did it. Just look it up, and they did a whole investigation into web shells, which highlighted the fact that these are one of the biggest critical issues for application security, and then we need to think about how to identify web shells and how to block them too. So some of the challenges and opportunities that we have is that we have this lack of secure coding education, and yep, that's an issue. But we also have the opportunity to help developers get the tools and materials they need to learn more. I mean, we are empowered to do that. There's no reason why we can't do that. And developers also have a lot of deliverables and high expectations. There's a lot of pressure for them to build, build, build. So maybe that's an executive management type of conversation where the sprint cycles, which in many cases are like 2 week sprints and everybody has to get it out, has to be reevaluated. And the vulnerabilities that are being produced, let's say by the tool chains that are being incorporated into the CI and CD pipelines, those things need to be either better instrumented, or there has to be more time taken to really analyze what a vulnerability is and what prioritization that vulnerability needs to be given into the development workflow itself. It's okay to take a step back and say, is that vulnerability a prize 0 or is it a prize 3? Can we push that out into production now and then come back, because it's not going to have a dramatic impact on things, to say like PII or a threat actor breaking into our systems? Those are things that are valid conversations, and that's part of the threat modeling also too. I think taking a step back, and you've probably heard about shift left and saying, let's shift left and start thinking about where some of these threats fall into the conversation. That's valid. Take a step back, do a shift left, and say, how do we prioritize some of these things? What are the vulnerabilities that really do break the build, and how do we solve for that? And then we have, of course, technical debt, and that is really hard to solve, because if you have old systems out there, old code, you have to figure out, do you air gap that? I've talked to customers in the past that they air gap old systems that are running on Windows XP, but they need to have it running, and it's the only version that the software only runs on Windows XP. That's it. And so they air gap it. So technical debt is something that has to be considered. And so there are solutions for it, like hiring somebody who's going to manage that code base going forward. But part of the problem is that most developers don't want to work on old code. Once the code is done, they want to go on and move to the new shiny. So I think there has to be some understanding. Somebody has to come to understandings of who is going to manage that technical debt and how is it going to be managed, and how are you going to isolate it if you can't manage it in the right way. And then there's also the opportunity to show that putting in security tool chains or tools into the development workflow doesn't necessarily have to be additional work, especially if you have good tools that demonstrate what the vulnerability is about, how to remediate it, demonstrate the code in a way that developers can digest and actually take action upon it. You see, developers, they work on bugs all day long. They know how to manage bugs. And maybe we need to start thinking about security as part of the normal QA cycle and show developers that, yes, a lot of these bugs security issues are actually bugs. And interpret that as bugs, they might actually perceive it a little differently. They might say, "Oh, okay." But here's the catch. You have to give them actionable information. You cannot just say, "Here's a tool. I'm going to insert it, and you're going to use it, and you're going to solve all security issues in the world." It doesn't work that way. The tools have to be something that makes it that are effective to solving the development problems. And in so many cases, what's happening is developers are being brought to the table and they're saying, "Hey, we have all these tools," and the developer's saying, "Well, I like that tool." And then you have I'm going to call it the parent figure sitting in the back. And the parent figure is typically the AppSec engineer or the CISO or a CIO or somebody who's writing the checkbook saying, "Yeah, I'm glad you like that flavor, but you know what? Instead of giving you, that flavor, we're going to force you to choose the other flavor because that's the one we're going to choose." So developers don't have that say then. And in many cases, if you bring them into the conversation and you allow them to evaluate the options, they're going to give you great feedback that's going to tell you this is what's going to solve our problems in the most frictionless way possible. Because ultimately, automation is a developer's best friend. They want to automate everything as much as possible because they're spending so much time writing code. So if you're writing code all day long, in many cases, you just want to press that button and have it go out into staging and production and be tested and make sure things are going fine. So that way, if you do find an issue, you can just solve it and go back into the code and go forward. Automation is a developer's best friend. And if there's one phrase that I want to kind of emphasize to security practitioners, is automation is a developer's best friend. Think about that when you're going through your selection process, whether you're trying to select a SAST or a DAST tool. Think about that and try to bring in the development team to help you make the best decision for what they actually need, not for what you feel is the right choice for them. You have to partner with them to make the right decision because, when you're trying to think about building security into the pipeline, you want the developers to be there and have that say because they are touching all these different tools. They're in the IDE. They're working in their CI pipeline. They're working in their CD pipeline. They understand how all these tools factor into the build process and how long it takes for things to happen. The longer something takes for code to go from development to staging to production, the more pressure the developers are under from management because ultimately, especially in modern times, most management wants the code out quickly. That's why they've shifted into agile process. That's why you have DevOps. That's why you have DevSecOps. There's so much pressure on development teams to get code out quickly and get new features out quickly. So anything that's going to add friction to them, they're going to reject it. Give them the opportunity to have a conversation with you to let you know what are the things that would break the build and what are the things that would cause friction, because ultimately you want to empower developers to innovate in the most secure and frictionless way possible. All right, I can't stress that enough. Now, one thing that I'm a big fan of is learning by doing. I think that as security practitioners, you have a great opportunity to show developers how to actually do stuff. How do you actually I don't know what's an cross-site scripting attack? What is SQL injection? And by showing them that and then correlating that to the actual code that they're using, it kind of reinforces why they need to take steps to write code in a specific way that's going to prevent these things from happening. I guess that's the best way of describing it. And so, like OWASP, I mentioned OWASP earlier. OWASP is such a great example of this. They have something like JuShop, which is a very modern and purposely vulnerable application. And it's obviously you can get it from the OWASP.org site, and I'll show you that in a second. But there's other vendors like Veracode, the company that I work for. I'm their security relations lead and developer relations lead. You can get it from Veracode, but you can also get it from TryHackMe, another hacking type of service. It's really important to get hands-on. I found that developers learn by doing, and when they do stuff, they actually it helps them grok a little bit more what's going on. And so, in fact, one of the things I've been trying to do is I have a Twitch stream myself, and if anybody wants to come and check me out as I'm doing my application security stuff and hacking, by all means. But this is actually a screenshot of a video I took when I was going through JuShop and showing how vulnerabilities happen. And so the way I like to do it is I actually send people to the JuShop website. Let me go over here, let me switch, and you can see that, and I'm turning my face because I'm looking, I have multiple screens, so I have to look at this over here, but you can see that here's the OAuth Foundation. It's a great resource. If you really want to learn deeply about application security, I can't recommend the OAuth Foundation enough because they've taken so many steps to provide you with all the information you need about the common trends in application security. Now, to me, one of the things I like to do again is learn by doing, and I think being hands-on is important. So I always send folks to JuShop, and now JuShop, it's a purposely vulnerable application. It incorporates Node.js, Angular, I believe it's MySQL, and Express, and so it's a pretty relevant stack nowadays for application building. And then there's a variety of opportunities for a threat actor to go through and compromise the system. And so there's multiple ways of installing it. So you can go ahead and actually even deploy it. If I go here to GitHub, I believe I can even deploy it from Heroku, which is kind of cool. Now, normally the way I do it is I create a VM and like an Ubuntu VM, I'll install JuShop on there, and then of course I'll attack it that way. And the reason is because I prefer to have things kind of protected. When you're taking a purposely vulnerable application, you have to take a lot of care, especially in a corporate environment. You don't want to put something out there. So that's why I'm kind of putting the disclaimer out there about certain things. Just be careful when you load these things up and where you install them. You don't want to expose this accidentally to the public and then it compromises your system. But yeah, for example, you can click on here and go to Heroku, and then when you click here, it'll actually install a Heroku instance that allows you to tinker with JuShop directly. So you don't even have to do this in a VM if you don't want to. You can just sign up for Heroku, and I think Heroku gives you some free credits, and you can play with JuShop directly there. All the code is available to you. So here's the great part about it. Not only can you go ahead and install JuShop and actually hack at it, but you can correlate certain things to code base, which is important to reinforce stuff with developers. Remember, we're trying to teach developers why security is important and where these security issues fit within their code bases. And so if I go to JuShop, for example, and I have JuShop here running, again, I'm running it on an Ubuntu instance. Here's JuShop running. It's just a simple npm application, a node application. So I just do npm start, which starts up the instance. And then from here, I can just access it really simply through my browser. And it looks like any normal type of application, but the cool thing is that you can run through this and demonstrate, oh, well, here's an email address. I can use that in some fashion. Explain what a threat actor might do. And I'll give you an example. Mind you, I've done this before, so I'm kind of cheating, but I know that if I go here and I say, all right, if I go, I don't know, boom, or 1 equals 1, and I'll copy the same thing in here, I wonder what could happen here if I do this. All right, I do that, and guess what? I got immediate confirmation that I've compromised an actual account. And so this is the type of stuff that helps reinforce some of the things that developers might experience in a real world and how a threat actor might actually tinker with their application. And so if I go here, sure enough, I am admin at JuShop, But it's also cool to show them that, look, if you go here and just use regular common developer tools, well, here's their JavaScript file. And what if I said, all right, I'm going to search for scoreboard. And scoreboard is something that I know is in here, but part of the reason is because the code here it's packed. And so many developers believe packed code is obfuscated code and nobody can compromise it. And we need to make sure that they understand that no, you can prettify it. Firefox has something that can let you prettify the code. And there it is. And then you can even search through it. And threat actors will search through this and say scoreboard. All right. And here, and I can go to there and search and say, oh, okay, there's a path called scoreboard. So let me copy this. And I'll go this and see what happens now. All right, great. So now I found the scoreboard. And so these are, it's important to demonstrate these things and show that things like packing and obfuscation shouldn't necessarily be viewed as a security boundary, that a determined threat actor could get to some of these things and wreak some havoc. But then you also want to kind of correlate some of these things to the code base. So you want to be able to go to, let's say, the login page and say, all right, here's the code inside of JuShop for the login page. And this is where you're accepting unsanitized input from the user. And this is where you're not ensuring that your SQL is parameterized in a way that's not going to cause a SQL injection attack. The same for a search. And so maybe you're going to do something in here where you're going to accept a search criteria, but you're accepting input that could turn into a cross-site scripting attack. The bottom line is that you want to give developers not only the experience of seeing what a threat actor would do with their application, but you want to reinforce it by showing them where in the code some of the things can happen. Correlate the two, because then it reinforces that these are the areas that are really important for you to consider when you're building out your systems, and you want to build it out in a secure fashion. As we go along, again, this is try hack me. Try hack me gives you the opportunity to do JuShop just like I did here, but they do it in a hosted environment. So it's virtualized, it's not on your system, it's protected. And the same thing with Veracode, the company I work for. We have Security Labs Enterprise, which not only offers that same type of JuShop experience, but also offers a bunch of other exercises that help developers understand secure coding practices. But the way I look at it is security is a dual responsibility. You can show developers stuff, but it's also a responsibility for security practitioners to learn what it means to be a developer. And I'm not saying that you have to learn how to code, an application, but I think it's important for you to spend time and understand what developers need during their day-to-day, and then how does security fit into that. So many times I hear security folks thinking the other way around. The developers need to think about security. But maybe security practitioners also need to think about development and how security fits into that. And if you haven't taken that time, maybe you need to rethink that a little bit and say, let me spend some time with the development team and think about what are the challenges that they're facing from a development lens. Spend time with them and teach them about the cyber attack kill chain. Walk them through what a threat actor would do, whether it's reconnaissance or weaponization. Think about what an exploitation looks like. Explain what a C2 is. In many cases, it's important for them to have this understanding. We're not saying they're going to become security professionals, but if you give them an understanding and a lay of the land of some of the things that you're seeing, then I think they might start considering some of the challenges that you're facing and how that applies to their code base. And also demystify what a threat actor is. So many people, and this is the media, of course, the threat, they want to put some person in a hoodie sitting in a secret room doing all this stuff. And sure, there might be some folks like that, but the majority of them are just average people who have really good skills. And they might wear a hoodie because they're cold, but they don't wear a hoodie because they're a hacker. I think we need to demystify this a little bit. We need to get folks to understand that, yeah, this person is not a real representation of what a hacker is. This is just the media's representation of what a hacker is. And one thing I've realized is that when you start talking to folks about security, eventually they're going to self-select. You're going to find folks who are going to be really interested in this. I'm an example of that. Security piqued my interest. I was a developer for a long time, but security got me. And when I went to my first DEF CON, I was hooked. That was it. I wanted to be in security. So these folks will self-select, and you have the chance to kind of cultivate that relationship with them, build that trust, help them better understand what's important from a security lens. And then once you do that, the other part that's important is the follow through. You need to give them the tools necessary for them to understand how does security fit into development. How do you write secure code? What is application security? What does that mean? All right. And like this book, the Web Application Hacker's Handbook, that was one of the first books that was recommended to me when I got into security. It's like the Bible of web application security hacking. And so these are things that, in my opinion, are low cost, low friction type of tools. Most people like to read. I love to read. Give them the books, give them tools, things that will help them learn to be more successful security practitioners within the context of their code base. Help them be successful in the things that make them excited and enable them with the right tools. But then again, you need to understand what their tools look like. You need to understand what is their process for getting stuff out, because that's the only way that you're going to be able to effectively secure things. And it's the only way that you're going to be able to effectively partner with them. You need to speak to their language. Developers have their own unique language, their own unique cadence, their own unique tool needs, and you need to understand that. You need to spend time with them, and you need to just show a little empathy because their work is really challenging as well, and I've lived that. So I'm trying to get better at this. I'm trying to better balance my understanding of developer workflows as well as where security fits into that and how I can help developers become more successful at that. If we do this, I think we have a really good opportunity to build more folks that want to get into security, and we need that. We have a need for like 2 million cyber defenders, and we need more folks who are willing to jump in and become those security champions, folks who want to make sure that we don't suffer the next SolarWinds or Kaseya attack, or that we don't have the next npm issue coming down the pipe. It's important. And if we spend the time to learn what developers need and give them the tools that make them successful, and also advocate for better security training, not only in the university settings, but also in corporate America, I think we're going to get there and we'll build some better and more resilient applications. So thank you so much for your time. I really appreciate it. Again, my name is Ray Bango. I'm a security and developer advocate for Barricode, and I'm so happy to have been able to deliver this presentation. Take care.